Hello, and welcome to this webinar presented by the volunteers of the IET's Cambridge Network. We represent members in the Cambridgeshire area, but we're very pleased to welcome folks from around the UK and indeed globally. My name is Phil Zerngast. I'm the chair of the local network and I'll be your host tonight. Now, before we come to our speaker, I will mention a few points of housekeeping. We will be taking questions tonight, but if we can leave the answers to the end of the event, please. You can post your questions by using the Q&A button, which you'll find if you wiggle your mouse at the bottom of the Zoom screen. That's the Q&A button, please. We're recording the event and that will be available in a day or two's time on our YouTube channel, which you can find by searching for IET Cambridge. And finally, I'll mention our next event, which is on the subject of recycling and the approach that the co-op is taking to recycling. And that'll be on the 24th of February. Now, on to tonight's event. And we have a very large audience tonight, possibly one of our largest in the last 2 years of running Zoom events. And I think that reflects the interest in the economic and environmental impact of this technology of heat pumps. So I'm very pleased to welcome our speaker, Warren Pope, to share his insight. Warren is the retrofit project manager with Retrofit Works Limited, and they seek to design and implement energy efficient retrofit programs in the Cambridgeshire area. Warren is an experienced project manager with a long track record in engineering and manufacturing, construction, and the energy sectors. He's also a lead assessor for energy saving projects in building, processes, and transportation, with extensive experience in the built environment. So without further ado, I will hand over to Warren Pope.
Right. Good evening, everyone. Nice to be here. As I say, I work for Retrofit Works. We do also have other schemes that are running in London, Oxford, and in Sussex. Now, if we go to sharing the screen, I will get started. Right, I'm going to have to be moving at a bit of a pace on this because there are quite a few slides. You'll see as we move forward. I've actually put further information at the back of the presentation, which I won't cover or speak through. There's some reference stuff, places to go, websites, and an acronym buster. I'm also managing a ERDF funded energy project, and there are details of that at the back. Now, with a heat pump, you need to ensure that you have someone that is MCS qualified as you run through the stuff. You need to have your heat loss calculations undertaken to ensure that the sizing of the radiators and tubing that you have in the installation, should you go that way, are the correct size. It makes allowance for the different insulation types that were in the building at the point in time. And you will also need to have a valid EPC certificate in order to
Warren,
help.
Yeah. Can I just interrupt you? We're not seeing your screen at the moment.
Ah, right, I know what I've done. Beg your pardon.
That's fine now, thanks.
Yes, I forgot to click the last button. So, yeah, so here we go, details of where the slides are for later. Running through, you do ideally need to have a property that's well insulated. There are what's known as hard to heat homes. We'll cover those later with alternatively. One of the other most important things to do is to ensure that when you're siting a heat pump, that it's clear from debris and other bits and bobs. It's kept clear, serviced every year, and ideally to have it on the ground so that when it comes to servicing, you don't have to have someone on a ladder or going up high to try and reach it to work with it. We will cover the different types of heat pumps that are available in a little while. But do bear in mind, if anyone is thinking about a ground source heat pump, it can add a considerable amount of cost to the actual installation. Now, the efficiency of the heat pumps. Generally speaking, They're measured by the coefficient of performance, or the COP, which is most people in the industry would describe it. Very simply put, if you have a device which has a COP of 4 for every 1 kilowatt of energy that goes in, you'll get 4 kilowatt that will come out. So if assuming that you're spending 13 pence per kilowatt, for every 13 pence spent, you'll get 52p's worth of energy as it runs forward. If you're going to be using a heat pump in your home, there will need to be some mild lifestyle charges. On average, a gas boiler will be able to heat your house up within about 30 minutes from scratch or from cold. For a heat pump, it will take about an hour. Generally speaking, if using a heat pump, you'll need to have it on perhaps at a slightly lower temperature to you would a gas boiler, but have it on for longer during the day. Now, most people are aware of the renewable heat incentive, and also it's coming to an end at the end of March this year. It's going to remain open to the applications, as it says, right till the end of March, but you will need to have the device signed off by the MSC specialist in order to get your renewable heat incentive. On the point of the installation, it is important to ensure that you have a contract with the installer, so they actually will guarantee the amount of heat incentive that you will get. It is unfortunately common that some of the installations are not that good. They do not always reach the required parameters for the renewable heat incentive, and then you could then end up having to fork out the full amount of money out of your own pocket without actually being able to get any of the grant funding. The RHI is going to be replaced by the boiler upgrade scheme, as it says on the screen, running for 3 years from April 2022. One interesting figure to look at is that at the moment, £450 million has been set aside. That can supply 90,000 grants, yet the target is to put 600,000 heat pumps in every year until 2028. You will need an EPC. EPCs varying from A for very efficient to G least efficient. There are exceptions on buildings that you can use. Typically, it needs to be an existing building, or there is a phrase that has been used, a custom built, or custom made. I haven't been able to find out what the official definition is of that just at the current moment in time. If you're in a conservation area, there is an opt-out, and if it happens to be a government-owned building, there is also an opt-out for that. The scheme will work via vouchers, so it is down to the person that wants the heat pump to, or the other technology that's available, to actually apply for the voucher, and then it's the installer that will actually redeem the voucher for what's required. Now, the Clean Heat Grant, it will cover air source heat pumps, ground source heat pumps, water source heat pumps, which we'll cover later, but also it will cover biomass boilers, as long as they don't have a back boiler. And then there are yet to be seen just how the scheme is going to move forward as they are, and they will still need to have the heat loss calculations undertaken to make sure that the devices can be sized correctly. Now, we spoke about COP previously. Now there is another phrase which is FPF, the seasonal performance factor, because the air source heat pump, which is the most common type, more on that later, are drawing heat from the air. When you get to winter, it will have to work harder in order to extract the same heat in order to keep the place warm. Therefore, when the calculations have been done by the heat pump installer, you need to make sure that you have an SPF of 2.5. And that is just doing the calculations to ensure that, depending on the rating of the heat pump, that it will still be able to keep the building warm as and when it moves forward. There is, in the slide where I mentioned there about the micro bore pipe work, the heat pump will work by pumping a high flow of water actually going around. Typically, a gas boiler is going to be somewhere near around 80 degrees as it comes out. The heat pump, high temp ones, they're going to be closer to 65, possibly even 55. So there needs to be a high flow of water going around the pipe work. Generally speaking, normally bigger radiators so you can soak the heat into it. A heat pump will work on a micro bore pipework for a short amount of time, but because it has a high flow rate, it will strain the pump trying to flow the water around the narrow diameter and will eventually wear the pump out. And I'm assured by some experienced installers that generally the water circulation pump will die within about 12 months. If that happens, it will not be replaced under guarantee, and it will be a requirement for the heat pump owner to actually pay for the pump to go in itself. And then that would be another annual expenditure that you would have to have. So ensuring that the correct size pipework is used, which is somewhere between 18 millimeter to about 22 diameter, is very important. One of the other products which is available is the SunAmp device. To call it a instantaneous water heater is unkind. It has phase change material in it. It's used as a heat battery, so water can pass through to be heated. These can actually be connected to the heat pumps as well. The SunAmp product resembles a small fridge. There are lots of addendums and caveats as to what devices they will work with. If you follow the web link there, you can get all the information you need as to what will be suitable and what may not be. Now, as I've mentioned to a number of my colleagues before, there are alternatives to a heat pump, not necessarily as efficient, but there are ones out there depending on what sort of state the house is. And sometimes it may be necessary to consider a secondary heating source to a heat pump if there's particularly inclement weather or something that's really cold. This is one of a product that's come into the country, Lenama Heat. It can actually be embedded into the plaster of a ceiling, or it can actually go on the floor and even in walls to add an ambient heat as and when or if required for additional heat coming through. And then you could also consider infrared heaters. That device there is actually the infrared heater. That mirror finished is infrared, and then you can get netting that can actually go under the floor, and it can even be embedded in the plaster in the walls as well. It's a direct radiant heating rather than convection, so it will heat solid mass, it will heat people, but it just has to be directed in order to get the best benefits from it. This is some of the most recent equipment that I've seen that's come onto the market. Again, it's not a storage heater, it is a thermodynamic fluid filled electric radiator, but this has been fitted with artificial intelligence. The example I used earlier today explaining is that if you have a 3 kilowatt fan heater, you turn it on and you'll continue to get 3 kilowatts of energy consumed until such time as it is turned off. The software within these radiators will, you can actually set it to a set degree. In this case, as you can see in the top left picture, 19 degrees. The radiator will heat up till it achieves that, and then it will start ramping down the power. So it won't continue to ramp at full rate, which then allows a reduction, and then it will just top up the heat with little increments as it's required in a step-by-step basis in order to keep the rooms warm. If you're in care homes, student accommodation, or as in retirement areas where it's not particularly well set up for a wet-based system, such as a heat pump, again, these will not necessarily be as efficient, but they are a suitable alternative. They can be run with batteries. They can also take power from PVs. If you were to install a standard set of, say, 1980 storage heaters with these, you probably have a 40% saving nearly overnight. This is another new product that has only just started being manufactured around about November last year. It is a electric, near enough a boiler, but again, using phase change materials. It's designed to become a heat store inside. Again, can be run off of a battery and PV. Because it's electric, you need no flue. So if you're in one of the harder to heat places, you could actually take your gas boiler down, put this in its place with very little changing. It doesn't need any specific pipe work or radiators to it. It will work on what the existing area is. And again, will work pretty much to the same temperatures that a normal gas boiler would work to. Being fitted to either battery, PV, or if the time of use tariffs come in, it's an area where, again, you can make savings. Certainly you'll get the carbon reduction, But again, not quite as efficient as a heat pump, but not far off if the aim really is to reduce your emissions rather than particular monetary based. This again is a new product that I saw being demonstrated in the Cambridge Cleantech presentation. That's the actual device in the background. It's made from minerals that have been recycled, heated with electrical elements. It is quite suitable, and again, I was explaining this morning. If any of you that have been to Hitchin, Letchworth Garden City, they have a range of houses that are sort of like circa 1950, between 5-6 bedrooms, really quite big, sometimes with timber frame or even solid wall. That's the sort of building where one of these would come into its own. A heat pump potentially might not cut the mustard in order to keep the place warm. This product is not cheap. I saw it advertised at 12 grand, albeit that is round about the same price as a heat pump. It's notable though that you cannot claim the renewable heat incentive on this device at the current moment in time. But again, it is an alternative that can be used if it's going to be difficult in order to have a heat pump used. Here we come into the main range of the heat pumps. The most common one which is in the UK is a air to water heat pump. They can come in high and low temperatures. The hybrid systems are available. That's where you would run a gas boiler with a heat pump. Some of the fossil fuel companies have been promoting them quite a bit in order to keep going with gas, oil and other supplies. There are a number of brands that are around. There are restrictions as to what they can be connected to. The only issue with having certainly a hybrid system is that the heat pumps work better when it's really hot, not so good when it's really cold. And of course, in summer, you're not going to really need to use the heat pump that much. But it is one of the other ones that are available. With your, let's move on to the next one first. With the air source heat pump, draw the warm air in, cold air comes out the back, and then it can be circular during the heating system. This picture here shows underfloor heating, because typically that is really well suited to. In the picture on the bottom right, you need to ideally make sure that you have the base model about 300 mil away from the wall. Some might require 500. That's so you can draw air in from behind and from the sides, and so you can allow the cold air to escape straight out the back. When it comes to the positioning, as I said earlier, ideally best so you can actually reach it on the ground, so you don't need scaffold or ladders for it. And also making sure that they are kept clean and free from vegetarian or grass and weeds and so forth. It's not that uncommon to actually find these units with weeds, grass literally growing into them at all areas. Needs to be basic service every year to make sure that all the fans, foils are all cleaned out. Any debris is sort of hoovered out, cleaned of dust, leaves and other so forth and other bits and bobs. Now, heat pumps will come either as a monoblock or a split unit. Split units are generally more expensive because of the gas that you need to move towards them. The most typical installation would actually be a monoblock unit on the outside, because then it does all the heating, cooling, the heat exchange in one go, and then the pipework goes straight in to move the water through. The occasions where you might need to use a split unit would be in a conservation area. They can be placed up to about 30 meters away from where the actual building is. So if they need to be hidden out of sight for conservation purposes, then they can be used. But they are expensive, and that's predominantly because there are not many F-gas engineers available, so they can charge a bit of a premium. This is a colleague of mine in the picture at Busy Energy. Here's an APIT inspector. This is what I would say is far one of the best installations that I've ever seen. Everything insulated, everything tied off, nice and neat and tidy. Depending where you are, a planning permission might be required. sometimes for domestic purposes, although it could also be considered as permitted development. So it's worthwhile checking on the areas where you are to see what's required. There are certain positioning areas where you need to be careful. They need to be, I believe it's at least a metre away from the neighbour's property. And the compressor unit, including the housing, must not exceed 0.6 cubic metres. And yes, just double checking, yeah, at least 1 metre away from the property boundary. It is possible to install them on a pitched roof in a special frame or on top of a flat roof, but again, special permissions may be needed from the local authorities in order to do that. But then also at the same point in time, you still have the access issues to consider. And the other thing is, bear in mind, as it says on the bottom of the slide, making sure that you have a sufficiently sized plant room or area for the equipment to go to, so you can actually get into, service it and deal with it and make any changes that are required. An image of a hybrid source pump, and this is from FAM News, which it just escapes me what the acronym is for FAM. It has to be said at the moment. One of the local industry. Oh, there we go. Plumbing, Heating and Air Movement magazine. With the hybrid, so again, it can be used with sort of some of the traditional radiators, or certainly those that are on the gas size, depending on what the heat water setup is. The phrase emitter that we have in the pictures is what the industry uses for the radiators. And again, the sizing depends on the heat loss calculations that you have. One example that I tend to use is that in my home office, I have a radiator, which is a single skin, approximately 900 mil in length by about 700 mil deep. That would need to probably change to a 1.2 meter long and a double skin, potentially, in order to deal with the lower temperature as it goes around. For the ground source heat pump, this is the slinky method, where you dig a hole in order to sort of go across the garden if you have a large sort of grounding area. To install a 11 kilowatt ground source heat pump, you would probably need approximately 700 square meters in order to fit the slinky in to get enough ground scope. A survey would need to be undertaken on the ground type that you have. It's difficult to retain the heat if it's very sandy, and if water can flow through easier where it is. Clay typically is a bit better. If you are considering a borehole, it's reckoned that on average you'll probably need to go about 100 meters deep, and you have a diameter of about 250 millimeters. That would power a 5 kilowatt system. So if you're going for something like 10 kilowatt system, you'll potentially need 2 boreholes. And then they would also need to be around 5 to 6 meters apart in order that they didn't soak the heat out from where the other borehole was. The water source heat pumps work really well. Just going back to the slinky, you would need to be at least a meter, ideally 1.5 meters down. At that depth, it's protected from frost when it comes, and at that sort of depth, it has the ground has quite a reasonable temperature, or regular temperature, shall we say, which is normally around about 5 degrees. With the slinky based water source heat pump, it can, generally speaking, get around 5 to 8 degrees Celsius from the water, which is a really good medium to actually sort of take the heat out from. If you're in an area that has been mined or has other boreholes, it will be possible to use those to extract the water. And also, if you have a water-based area, say a large lake or a river going by, then they would be quite suitable for a water source heat pump. Perhaps went a bit too quick there at the minute, but I think we're close to the 7 o'clock mark. So thank you for listening to me rant on, and are there any questions?
Okay, thank you, Warren. There are lots of questions. So I will hand over to David Blake to
Hey.
take you through that. Thank you, Warren.
Thank you, Phil. We do have a lot of questions. Some are copies of one another, but I'll try and sort of go through from question one to go through it. First question we have is, how does one stop the evaporator icing up?
Sometimes you might have to fit and then just let a heater in order to just have a little bit of heat wafting through.
Okay. And there's a complementary question. If you live in Aberdeen or sort of out farther north and there's lots of snow around and snow build up around the system, the outside system, how do you cope with that?
Potentially not use a heat pump, I think would be the initial answer. Yeah, it's like PV units. The further north you go, it can be that the less effective they are. If you are going to be in a very high snow area, it would need constant clearing. And I think with the temperature that you get up there, I think an alternative heat source will be the better route, possibly even something like a heat battery.
Okay, somebody passed a comment that air source heat pumps are used a lot in the Scandinavian countries, so presumably they have a supplementary heat system or something.
Yeah, some do, although the Scandinavian countries are not as humid as what the UK is. We have a lot more moisture in the air, even though they have lots of snow. It's not that particularly wet up there. They have the better chance because the air is drier.
Okay, I will just interrupt a moment. There's quite a few questions asking, can they get a CPD certificate? Perhaps I can ask my colleague Phil to email on chat that it's camsec@gmx.com and we'll send one out when time becomes available. Thank you.
That's fine.
Are there fully electric systems available where additional heat can be introduced via an electric boiler when required? The boiler would sit in the wet circuit downstream of the heat pump to add another 15 to 20 degrees to the water temperature for a limited period. I think it's probably on a temperature boost.
The answer to that is I believe it's possible. The reason why I say that is because we have a property in Cambridge on the Accordia building site, which has an issue with he's been unable to get a quote for a heat pump, which I suspect is because the water will not be warm enough when it returns. We're actually going to be using part of the ERDF project to actually look into that to see what can be put and how it would work. The only real issue I can see is matching the flow rates and the pump rates for getting the water recirculated back. But yes, it should be possible.
Okay. With underfloor heating, what range of floor temperatures can be achieved typically, and how does this compare with electrical underfloor heating?
Well, normally the water will go in at about 55, 60 degrees, and then it will just be enough to soak for a while. There is a word of caution. With my colleague Adrian that I've been talking to, it is possible to have an underfloor heating set up with a gas boiler, which may not be compatible with a heat pump, so that needs to be considered up front. I believe it's to do with how tightly the coils are at under the floor, which is the one thing. But again, it's one of those with your underfloor heating, it just needs to be left on for longer, and that should work its way up. With the electric heating, again, I suppose it's going to depend a bit on what the flooring's like and what type you've got. I've not actually experienced the infrared heating mats themselves. I've seen other heating mats that have been printed with conductive ink. But yeah, for a direct comparison in actual, I've not come across one yet.
Okay, excuse me, my phone. Yeah. Sorry about that. I switched everything off, I thought, but not the mobile phone. Are there small-scale single radiator heat pumps for a flat, not air-to-air? I think with the increase in the number of flats around Cambridge, certainly that's quite a sort of a big issue for a lot of people.
Yeah, I mean, you can get as low as a 5 kilowatt heat pump, which probably will be suitable. I'm not entirely sure that air to air is going to be covered under the new renewable heat grant. Partially because the air to air units can be reversed and potentially used as a cooling unit. And if there's any possibility that that can be done, then the RHI certainly would not be issued. The only other requirement then is where the external unit goes. Again, there are height issues, and in particular in the area in Accordia, there's a sound decibel limit for having a heat pump. And in order to get even that, the chap had to get planning permission for it. You can get acoustic covers for heat pumps in order to reduce the sound for it. But it's then just where they would be located in relation to other flats and other areas with how tightly packed they are. I've also already been to 2 Victorian terraces for doing the whole house plan for retrofit works. One of them had actually been encouraged to pay for the deposit for a heat pump, but there just physically wasn't the room to fit one in.
Okay. Going on from the question of schemes that the government might support, does a new build qualify for a boiler upgrade scheme?
No, it will not.
Okay. Somebody here says we looked at air source heat pumps, told the microbore pipes to our radiators mean that an ASHP would not be able to provide enough heat. Is there sort of something they can do rather than replacing all the microbore pipes?
No, not really. It's not quite so much that you wouldn't get the heat through. It would heat up, but it's the wear and tear that will happen on the circulation pump, which would wear it out prematurely. I have been in exactly the same situation with my own heating. I have microbore downstairs. I was looking at a cost of about £6 grand to strip the flooring out and chip everything out the walls and the floor. So I opted to go for a replacement gas boiler that was more efficient and one that can be converted to run off of hydrogen if that's the route we go down. I can't see that supplying the local grid with enough electricity for heat pumps is going to get sorted anytime soon. The new boiler will need replacing in about 10 years, and I think that'll be when the situation comes for deciding what route is next.
Okay. A comment really, this one. My Dimplex heat pump and buffer tank has 4 kilowatt electric immersion heaters included. In the past 10 years, the electric heaters have only switched on once, so really just a backup in case of heat pump failure. So I think what they're saying is heat pump in this particular situation seems to work.
Well, yeah, as I say, there are some buildings that they really will work really well in. The word of caution is just to be careful about doing boost on the heat pump, so you don't continually have all the immersion heaters running at the same point in time, because that could severely boost the bill.
Yeah. Then we've got, thanks Warren, what is the capacity for manufacturing heat pumps in the UK? Are they all sort of made abroad, and will we be reliant on large quantities of imported equipment and spares to keep them going?
Well, Mitsubishi are now actually making their eco down within the UK. I can't remember the exact location. Valiant are actually going to be opening a new heat pump factory later this year up in the Belper region, up near Derby. So okay. I think depending on how Brexit goes and runs, I think we're probably likely to see more of them actually manufacturing parts in the UK, which will be absolutely fantastic.
Okay. Somebody's passed a comment here. Can you fit a low loss header for microbore to work? Because obviously people have a lot of microbore around. They want to keep it going.
Well, my colleague Adrian, who was in the image, he just says no.
Okay. Why heat water? Why not just supply hot air? Aircon units do this.
Well, you can do that. That's what the air-to-air ground source heat pump is. It's just for whatever reason, it's not taken off in the UK, but it is possible to have one, and it's possible to have it fitted.
Okay. Personally, I used to live in a house with circulated hot air, and I thought it was pretty awful, actually.
Yeah, so have I.
Yeah. For heat pumps mounted at ground level or close to this, which Warren seems to be recommending, how badly are they affected by flooding?
Well, as much as any other piece of electrical equipment. I think if there's a flood risk, then that's where the decision has to be made as to what's the 1 in 1,000 year chance of flood levels, and then raise it appropriately. I've seen the flood modelling for where I live. One suggests that in 20 years we'll be underwater. Another one suggests we're going to be on the edge of a salt marsh. So, yeah, look for the local flood modelling. There is some available on a national basis, and then make that judgment call to just keep it out of the water.
Okay. Is there a facility to reverse the pump in summer and obtain cooling for your house, presumably via cool air?
Well, it can be done by the air and it can be done by the water as well. So yes, it can be done, but then you wouldn't be eligible for any form of RHI or new boiler grant.
Okay. There's a comment here, I think, and wants a question. 1 kilowatt of electricity is equivalent to 2 kilowatts of heat through the system. If the electricity comes from gas, that's 3 kilowatts of gas. 1/3 of primary thermal energy gets the computer, which in a gas boiler would give 2.7 kilowatts. I think probably they're trying to sort of say that, you know, perhaps the numbers aren't as exciting as they might seem at first glance.
Yeah, and then you've also got the variance for when it's winter and the machine has to work harder. A few people are skeptical about some of the figures that the industry give. At the moment, I'm going with the flow with the technical stuff. Mostly, people seem to think that they're doing okay. And if you don't mind me giving a plug for Cambridge Carbon Footprint, on the 24th, I believe they're doing an event for 2 people that have a heat pump installed.
Yeah. No, I can promote that through the emails that we send out to people afterwards. What are typical EPC ratings for both older and newer heat pumps?
I don't quite understand that question.
No, I can't say I do, actually. I don't know what EPC actually stands for in that context.
Well, the machines themselves will have an energy rating, albeit that's not an EPC, but the building has to start with an energy performance certificate, which is less than 10 years old. I think I've seen some that have gone up by about a grade, sometimes 2 levels, but it also depends on what the other interventions are done with the building as well. If you're going to put insulation in along with the machine, then you'll get a high jump in the EPC rating.
Okay. Is the energy use index of a building a reliable guide to its suitability for heat pump installation?
Oh, half the people I know would say yes, and the other half would say no. I think it would be as good as you can get at the current moment in time. Okay.
And there's a question about pipes. You said that pipes need to be 18 to 22 millimeters ideally, whereas, you know, most central heating is 15 millimeters. Does that mean that 15 millimeter pipes are unsuitable?
That would depend on the amount of pipe work that there is, and really it will be a decision for the installer to make when he's there, with to see what he thinks can be done. It could probably be used, but it's not ideal. And I was just chatting with a chap earlier this afternoon to say that it may even be, depending on the installer's choices, that if you've got a really large double skin radiator in a living room, you could perhaps recycle that into a smaller room in order to get the mass that you need to get the heat coming out. But that needs to be considered on, I think, a building by building basis.
Okay. Vattenfall have announced a hotter heat pump. Any comments about it? I think I saw it. It says it operates at a higher temperature.
Yeah, well, I'm not aware of that particular model. There are high temp and low temp. My colleague Adrian says that the low temperature ones seem to be having a slight edge on the high temperature ones, but there's no reason why it wouldn't be as good as any other heat pump.
Okay. Surely to get to the swap out rates that are going to be necessary to meet the targets, we're going to need units that can be a straight swap for existing combi boilers. Current offerings, are they just too complicated to do that?
Well, it's like all the technology, they're still working on it. I've not had that much to do with the manufacturing people for the different heat pumps, but I think the analogy will be to use that battery costs have come down by at least a third in the last 3 years. PV 4 years ago was about 1,200 quid per kilowatt all in. It's now at about 850. So the prices are coming down. It just depends how well they can carry on with their development works, really.
Okay. No heat pumps, but what's your take on microwave boilers? This type are designed as slot-in replacements for gas boilers. I've not come across those. You may have.
No, I've not seen microwave. I've seen infrared boilers, and from the people I've spoken to, the jury's still out on whether they are any more effective than a traditional one. There are some products around. I always confuse it and call it an energy miser, but it's not a miser, it's an energy mixer. There are more heated hot water cylinders that secure where the cold water entry goes into more, so it doesn't take the heat out that you've already got. Certainly some of the people on one of the Cambridge Carbon Footprint webinars actually have them installed, and they said they work really well.
Okay. Several questions about noise. How noisy are these systems? In other words, I think it's concern about upsetting the neighbours if you've got it outside on a wall.
Well, if I just go down the presentation a bit, I think the best thing I can say is I've got the bullet point for the examples of air source heat pump noise in action. Now, if you follow that web link, that will take you to the Busy Energy website, and he's doing a talk over of a low noise EcoDan heat pump, which I think is about 42 decibels. In a query about this, I forget what it was, but there's some other regular household activity often comes in at about 62 decibels. But I can safely say, if you had the low noise EcoDan outside your rear kitchen window, my current gas boiler is far noisier than what the heat pump would be. But it's got, it's very good. It's not hammed up, and then you can actually hear directly from the heat pump.
Okay. At best, a heat battery will have a COP of 1. So why should I ever prefer that over a heat pump, which would always have a COP over 1?
Well, it really depends whether your house is suitable to have a heat pump in the first place. The primary thing with the heat battery is that you can use electricity from PV and other renewable sources to actually be part of the heating process. And then it's also to do with the emission reduction, because by going from gas to electric, you get a reduction with that. If you can then use your energy from PV, you get even more. And then if you can get spare area to store in a battery, you can then improve your energy efficiency. But as I did say running through, it will not be as efficient as a heat pump and never will be. But it's just the only thing that's suitable for the building you've got. It's another alternative.
Okay. Is the air source heat pump best sited on a southerly aspect? In other words, presume you get a bit more sort of heat increase there.
I've seen no text to suggest that the aspect is that important, but yeah, I'd agree. If it's going to be there in the sun, it should help extract more heat.
Okay. I'm not sure you'll know this, but which electricity supplier gives 5p per kilowatt hour at the moment?
The supplier itself, I'm not entirely sure. Some of the big boys, they're doing this point of use tariff. I've seen some text saying that by 2030, they're trying to introduce it to a lot more people. This is where you might have 5 or 7 different tariffs during the day. The reason they're looking at bringing in the different tariffs is that they don't want people coming home with their electric car, if you can afford to buy one, and plugging them all in at 5 o'clock. So what it's suggesting is it might be as much as 40p per kilowatt at some point in time, and then down to 5 or even 2 pence in the middle of the night and the early hours of the morning. I know other people that are on the point of use tariff. It's not something I'm rushing to go to myself at current moment in time. It will be a matter of just hunting around. The Google search should do that.
Okay. There's several questions about where the air source heat pump can be placed, and people are asking if it can be placed in a garage or in a sort of a fairly open outhouse, something like that. Would that be okay? Does it have to be outside?
What I think to explain is that Mitsubishi, when they do their training courses, they actually have them working on a heat pump, which is inside the training room. And they make a point of closing the door when they're doing the training, when they don't realise. So they start beginning to get incredibly cold and just, yeah, really quite unpleasant. So you do need an open space. So long as you've got a well-ventilated outhouse, it will probably work. But it does need to draw the air in from the sides and the back. And if you're restricting the airflow, then the heat pump will not be as efficient as it could be.
Okay. New blocks of apartments tend to go all electric lately. This includes electric heaters and unvented water boiler systems. When getting an EPC, the results tend to be impractical, i.e. suggest storage heaters and other unrealistic minority improvements. As an expert in the industry, would the TEPEO shown in the slides be a better solution to unvented systems?
It's hard to tell. I actually have a meeting with them tomorrow, with them coming on, again, the ERDF project. So we can actually undertake further testing to see if that's going to be the case. But that was the other reason why I wanted to show the IntelliHeat radiators. They are another option that could be used in flats and so forth. Well, because I galloped through a bit, with the IntelliHeat heaters, you can actually have internet access to the temperatures of all of them. And what they've found so far, the manufacturers, is that, and the analogy that was given to me, instead of having a guy pop in a van and drive 200 miles to go and have a look to see what's wrong, they can actually go online and monitor the performance of them. I've been told, although again, I've only just met the chap for 2 days so far, or a couple of hours over 2 days. Their customer service approach is, if they get a call that says it doesn't work, they ship a new one out and ship the old one back, and they do it straight as that. Again, it's only offering potentially a 40% reduction in consumption. So it's not fantastic, but it is another alternative.
Okay. Somebody who's interested in what happens in the USA. In the USA, ground source heat pumps are used with air heating, cooling, and they'd like a UK version of this. Is that feasible, or is that not something that we do in this country?
It's not common. It can be done because it would work in the same way as an air-to-air heat pump. You could reverse it round. It's just that with the additional cost of the borehole, which you're probably looking at about 12 grand if you've got something like an 11 kilowatt sort of ground source heat pump, and then you've got the heat pump costs on top. If you're reversing it to using it for chilling, there's no grant available, so you'd have to bear the full cost.
Okay. And if we get to the point of millions of heat pumps in an area, will that have an adverse effect on the environment by itself? In other words, they're concerned that we may be moving from gas to lots of electric systems and maybe causing sort of global warming in that way.
Not so much global warming, but there would be the risk of taking all the heat out of the ground if you've got a really dense housing development and they all had a ground source heat pump. So there would be issues with that. I have, during lockdown and everything else, been listening to various webinars with the government about the use of hydrogen and their concept for moving forward. In 5 days, I've heard hydrogen will never happen. It will be at 20% on the grids, and then no, it's not going to happen. And then yes, we could probably do 50%. And it's been backwards and forwards. Just the one person came out with some reasonable common sense. They think the marketplace will move towards the mix of heat pumps, hydrogen, and then nuclear, unfortunately, is going to be the other option, as of which Rolls-Royce have just been awarded some huge sums of money to come up with the miniature modular nuclear power stations. And I think that is something that we'll end up seeing whether we really want it or not.
Yeah. Yeah. For new build properties, and this is an issue about sort of financial support from the government, can house builders, apply for RHI payments on behalf of purchasers where heat pumps are installed? In other words, there are any government incentives for house builders to install these at present rather than traditional combi boilers?
There would have been if the RHI was going to continue in its current format. There won't be quite such an interest in it. There have been a number of investors that were prepared to pay for the heat pump to go in return for receiving the heat payments. It was quite common about a year or so ago, but I'm not aware of that many people doing it now. There is a worry that me and some others in the industry have with the fact that some of the new build providers are actually still putting micro bore in, where it would make more sense for them to actually put the 1822 mil pipe in at the very beginning, and if they still wanted to go the gas boiler rate, put a high temperature one in. But that's where we are. So yes, it could have been, but it's out of fashion. It's probably not going to happen now. And if you're going to go and buy a new build, double check to see what size the pipework is they're intending to put in.
Okay. Do you know of anybody in the Cambridge area that could be approached regarding the cost of sinking boreholes? Is that in your list at the end of your presentation slides?
No, I don't have one for those. I can supply details of a chap who does boreholes. He's sort of just below Birmingham, but they travel nationally. There is a initial fairly hefty setup fee, so they've got to get the equipment to site, but when they're on site, it's relatively straightforward.
Okay.
If we can arrange for me to get their details, I'll email it out to them.
Yeah, well, we've given out the email address for CPD certificates. Just email any questions to camsec@gmx.com, and we'll see what we can do about answering. Did you say 700 square meters for ground source heat pumps, or did I mishear? Somebody was not sure what you'd said.
Right, let me go back to my notes. Yes, approximately 700 square meters or 837 square yards if you prefer old school.
Okay, well, please get people to know. At what temperature does the COP drop to unity?
Well, it's going to depend on the model, really. Most of the models will work to -20, -25. And that's probably when they get to the point where you're only getting 1 kilowatt for 1 kilowatt. Valiant, in one of their demonstrations, they're hoping to get to COP6, I believe it is. But then that's having an impact on the other efficiency measures that they have within the heat pump itself. I can't really be any more specific than that just at the moment.
Okay. New properties of electricity supply is rated at 100 amps and older ones at 66 amps. Does this mean a lot of properties will also need to upgrade their electrical supply into the house?
There has been a lot of talk about whether or not houses should be given a 3-phase supply, although that's mostly driven for doing electric vehicle charges. EV chargers is the other bit of technology that has changed significantly over the last couple of years. It's going to depend on really on how the heat pumps develop, but yeah, having a slightly higher supply coming in would be beneficial, especially if anyone is thinking about having an EV.
Okay. How are hybrid systems impacted by the proposed 2026 ban on fossil fuel boilers at work?
Well, as long as they're put in before the deadline, all well and good. But that is the deadline was for putting boilers into brand new housing. They're still going to be available. The announcement from the government actually did a surge in people going out to buy gas boilers for their properties, even when many didn't actually need them. So yeah, you'll still be able to replace an old boiler. It's just the new builds won't be able to have them.
Okay. What are the servicing cost requirements for an air source heat pump? You spoke of needing an annual service.
It would be much the same as for a gas boiler. If you're doing the outside unit and then the inside, I would have thought it would probably be in the region of about 100, 150.
Okay. Sorry, there's a load of questions here still. You've got a load of them. You mentioned solar thermal assist. Can you give more detail?
Yeah. Primarily, I was thinking of PV solar in order to actually heat up elements inside. But most the heat pumps that have a cylinder, you could actually have a solar thermal, which heats the hot water up, connected to another cylinder at the same point in time. For a standard panel, which from memory, roughly, I think is about 2 by 3 meters. You're probably looking at about £6,000 to have one put in. But for the PV itself, if you go roughly with about 850 quid per kilowatt that you want, that's all in brackets and everything. I've just had an estimate for my property. A 4.2 kilowatt peak system with a 13 kilowatt battery will be around about 7.5 to 8 grand.
Okay. And somebody's asking for your recommendation. If you were to design a new build house, what combination of systems would you choose?
I would go for going as close to passive house airtight standards as possible. And then I would probably consider having a air source heat pump, which is air to water. And then I would have the secondary heating, perhaps to be something like an infrared panel.
Okay. Is it practical to use rivers as a source of heat?
Yes, if you've got easy access to them. Unfortunately, it's mainly the mansions and other areas that do really well. Golf courses would be a good place for having water-based water-to-water heat pumps. And other venues similar to that, large hotels with lakes. But unfortunately, there are not that many domestic properties that are that close. But yeah, it would be a good area.
Okay. What is the maximum U value for a typical house that a heat pump can cope with? Can I judge from my EPC whether a heat pump would work?
Oh, it's not quite as straightforward as that, really. There are so many factors with different areas as to where it would be, and then what the heat loss is as well. I would generally say if you've got an EPC, well, I mean, you can roughly work it out because it will have the total kilowatt hours required to heat the property on the back of the EPC. But if you're looking at a D or C, then yeah, you probably should be fine. Failing that, it's worthwhile getting the estimate from the installer up front. Most, like my colleague Adrian, they can actually give you that as an indication from seeing the EPC and then just doing a desk-based study at no cost.
Okay. What are the most common faults with an air source heat pump? You know, what sort of is the issue that people have to look at?
The person setting it up getting the controls all wrong. It heats up too often is really the most common fault that you get on them.
Okay.
Oh, and I have heard of one other area where they literally tightened the tubes, the pipes up properly, and they flooded the place. Although fortunately that was a factory plant room. Okay.
How do GSHP compare with air source heat pumps on noise?
I've seen so few ground source heat pump, it's hard to comment, but if you look in the technical manuals on the back, there'll be a decibel rating for the different external units, and that would be the thing to base upon how noisy they would be. The one or two that I've seen, they didn't really appear to be any noisier. Those that were out air source heat pumps 20 years ago, possibly even 15, yeah, they used to make a real old racket, but the new ones are made so much better. It's not an overly thing that I would tend to worry about.
Okay, and there's a sort of supplementary one. There's a lot of vibration, which is passing vibration through the wall of a property, particularly if it's a terrace property.
That's why it would need anti-vibration mounts when fitted, and would need to be fitted properly to the pad stone or pads.
Okay. What level of insulation is required in a house? Are we talking about covering the walls, or is there anything else that we need to actually do?
Well, ideally, fabric first is the mantra that will certainly Retrofit Works has, and I always had at BRE. It's a matter of having the air tightness, making sure you've got ventilation rather than drafts. cavity wall, a good decent quality cavity wall would be good and should be good enough in actual fact. And then if anyone wanted to put external wall on, that's something else that could be done as an extra, but it would be a very expensive extra, somewhere between 135 to 150 quid per metre squared.
Okay. Hi, Warren. I'm from Burford in Oxfordshire, and in a local church hall, we have two GSP Kenza 25 kilowatt heat pumps that have both failed, along with 3 of the 6 boreholes within 5 years of installation. Did we use the wrong heat pumps, or any thoughts as to sort of what might be the cause of our problems?
Not really, without having a better idea. It also depends how they mean by the boreholes failed as well. Even for doing the boreholes, it's best to have a geological survey done to see what sort of ground is there underneath. If it's the sort of a very fluid or sort of watery ground, then that could be a reason as to why there's not been a great deal of heat coming out. And then the rest would depend on the setup. I did have a chat with my colleague Adrian. It could well just be something mechanical on the heat pump itself, and the person that's repairing it is perhaps not quite spotted the right bit to do. Again, if they want to send me some details, I can have a chat with them afterwards and then see what I can do. Okay.
There's somebody else who's looking at this similar area. I'm responsible for a museum in a listed building, about 300 square meters. Currently, we have a 65 kilowatt gas boiler nearing the end of its life. I've inquired about heat pumps and not found a supplier prepared to offer a system. We only need to achieve about 14 degrees for the museum. Should I give up looking for a sustainable solution?
Well, it's going to be difficult for the heat pump in. They did say listed building, didn't they? The museum.
Yes. Yeah.
They would need to consider the calculations of what they need in different areas. A product, perhaps something like Lanama heat that we had in the presentation, that could be embedded in on a very low temperature. But again, it would need some good calculations for what the cost would be overall. That would be my biggest worry to begin with. Certainly you'd have quite an emission reduction. The other option would be to consider perhaps something like the Intella heaters, which would be better than what they've got, but not as good as a heat pump.
Okay.
Yeah, it's hard to say. I mean, again, oh, does it say where they're based? Sorry, again.
No, it didn't. No.
Well, if they could put some stuff into the main question, we have a second project that we're working on, which is the Southeast New Eastern energy project, which would enable to have a 12-hour free consultancy for someone to go and have a look and do a survey. So you're looking at from Lincoln, Greater Cambridgeshire, North Herts, Suffolk, Norwich as well, all within the region. Unfortunately, the one at Oxford is just outside, but I can have a chat with a mate of mine about that one.
Okay.
Let us know where they are. We might have some hope that.
All right. Well, I think we've had don't want to sort of wear you out, but I'll just ask one final question. There's been several questions, because it's difficult to get them in a coordinated way, but relating to what happens in the event of power failure, and can air source heat pumps be run off of batteries, etc. I think particularly Storm Arwen has caused a lot of issues for people, and they got very, very cold. I don't think people want to rely just on air source heat pumps. You know, are we talking about a system that can be supported in the event of a power failure?
Yeah, it can be. If not go towards it, it depends on how big the system is as to how much straw there is. One thing to bear in mind is that if you've got any form of battery storage, it will come either as on-grid or off-grid. The typical format will be to have an on-grid connection. So that means actually when you get a power cut, the battery will normally turn itself off. The reason being is that if you send someone out to go and repair the line, and you've got a whole load of batteries or PV passing electrical current into the mains, you're going to electrocute the workforce as they're running there. So it would be worthwhile considering having some form of off-grid system, either so you charge it up, perhaps on a point of use tariff, or if you can do use PV to charge it up. So then when the power goes off, then you can actually still keep some power running through the building. Depending on the size of the domestic property, infrared uses a really low amount of energy to heat. So you would be looking at, for a standard convector heater, 3 kilowatts or 3000 watts. You could probably get something like a 600 watt infrared panel that will give out the same amount of heat, reducing a lot less energy. Some infrared panels, you can get the cheaper ones, which you can actually have on a stand and use them effectively like a bar fire, but at just a third of the energy consumption. I would hasten to add the really pretty infrared bit that I pointed out on the slide. The last I saw that was worth 1,200 euros because it's got a nice pattern and some Swarovski crystals in it. So wisely.
Okay, well, thank you very much indeed, Warren, because time's getting on. You must be worn out after all these questions. To let everybody know, if you have any further questions, you can email CAMBSEC, that's CAMBSEC @gmx.com. And we will put a copy of a video recording on our YouTube site over the next few days. It will take us a few days to sort everything out because we're only doing this on a volunteer basis, so we're not doing this full time. We'll also find somewhere to put the slides and hopefully a copy of any questions and answers. And I will email everybody who's registered to join this particular talk, both on Meetup and on IET Systems. So that's camsec @gmx.com. But please give us a few days to answer everything because there's already loads and loads of emails coming in. Thank you.
Yes, thank you. And I'll echo what David said. Very much appreciated for that really interesting and very comprehensive presentation that you gave. Both a positive but realistic perspective on where we stand. So that brings us to the end of tonight's event. So I'll say thank you to everyone for joining. I hope you all enjoyed it and found it as thought-provoking as I did, and clearly many others who posted questions and chatted with various perspectives online. So thank you all for joining. Please look out for our future events. You can find details of those if you search the Meetup platform, if you look for IET Cambridge. And you can also use the new IET NGEX site if you search for the IET local network. So on behalf of the Cambridge Network, I'd like to say thank you again, and you can all disconnect from this Zoom presentation now. Thank you.